Welcome back to Topic 5 for Algebra 1, Solve Problems Using Proportions. In Part 2, we're going to solve a word problem using proportions. A person who is 5.8 feet tall is standing 83.2 feet away from the lighthouse. The lighthouse casts a light on the person, creating a shadow. If the length of the person's shadow is 2.4 feet, how tall is the lighthouse? Round your answer to the nearest thousandth. What we're first going to do here is use cubes. So cubes, the first letter C stands for circle. So we're going to circle some important numbers. And I like to circle the unit that's associated with that number as well. So here we have 58 feet tall, 83 feet away, and 2.4 feet. Now we're going to underline the question, which is, how tall is the lighthouse? Then we're going to box any important action words. So a person who is 8 feet tall, we're dealing with the person here, is standing 83.2 feet away. The lighthouse casts a light on the person, creating a shadow. So we know we're dealing with shadows. If the length of the person's shadow is 2.4 feet, we want to figure out how tall is the lighthouse. So we want to ultimately determine the height of the lighthouse. And we need to round our answer to the nearest thousandth. Now we're going to evaluate and solve. So I have this diagram below. We're going to label it. Here we have a lighthouse. Now, since our question is ultimately asking us how tall the lighthouse is, we do not know the height. It was not given as a number in the problem. So let's just call it X. We do know, though, the height of the person. The person is 5.8 feet tall. So this person is 5.8 feet tall. And since all the units match, we know that it's going to be consistent across the board. We also know that the person is 83.2 feet away from the lighthouse. So the distance in between the lighthouse and where the person is standing is 83.2 feet. We also know that the lighthouse is casting a shadow. Let's see if I can get, or it's casting a light that's creating a shadow, I should say. So we know that the person's shadow is 2.4 feet. So right now we need to determine X. What is the height of the lighthouse? Now on the next slide, I created a table, which I think will be super helpful with determining the actual height of the lighthouse. Here I created a table, so we're just going to fill in the values. So, proportions are actually really interesting because as long as they are consistent, you can create different proportions for the same problem. So, for example, a proportion that you create might look a little bit different than your peers, but you might still end up with the same answer. So, for this sake, we're going to follow this template in order to determine the height of the lighthouse. So, what is the length of the person's shadow? From our problem, we know that it is 2.4 feet. So, 2.4. The actual height of the person, though, is 5.8 feet. Now, the shadow, there's actually a little bit of a shadow here from the lighthouse that is just capturing the shadow of the lighthouse and not including the person. So that distance is 83.2 feet, but we actually don't know the height of the lighthouse. So that's where we're going to put our X. Now we have our proportion and we can cross multiply. So we have 2.4 times x equals 5.8 times 83.2. Now for this, you can use your scientific calculator. I'm going to head on over to Desmos because I cannot do some of this math in my head. On the left-hand side though, 2.4x still is going to be simplified to be 2.4x. And on the right-hand side, 5.8 times 83.2. Let's go over to Desmos. 5.8 times 83.2 gives us 482.56. Now, because our problem asks us to round ultimately in the end, I'm going to try and write this number in my problem and not round ahead of time. The issue happens when students round ahead of time, their final answer will be a little bit off because it will not be as accurate. So I'm going to take this 482.56 and write that in. 482.56 or 56/100ths. Now we just have a one-step equation. So since this is 2.4 times x, we're going to divide both sides by 2.4. Remember what we do to one side, we have to do the other. On the left-hand side, 2.4 divided by 2.4 reduces to 1, so we're just going to have this 1x left over. And then 482.56 divided by 2.4. Let's head on over to Desmos. So 482.56 divided by 2.4 gives us 201.0666667. So the problem asked us to round to the nearest thousandths, which is the third decimal place. So in order to do this, we need to look at the fourth decimal place, and if it's 5 or more, raise the score. 4 or less, let it rest. So we have 0.0666. Our fourth number after the decimal place is 6. Since it is 6, then that means the third number is going to raise 1. So instead of being 0.066, it's going to be 0.067. So our final answer will be 201.067. Now, because we're dealing with a word problem, we're going to write our answer in a final sentence that actually answers the question. So again, the question is, how tall is the lighthouse? The lighthouse is 201.067 feet tall. And that was part 2 of topic 5, solve problems using proportions. Thanks for watching.